This is number 27 from the 2013 Mock MATHCOUNTS Sprint Round number 2. And it's about equilateral triangles, and you're told that your side lengths here are 1, 2, 3, and 4. And then you want to connect the points I and F, and so you want to find the length of that segment right there. Well, the natural thing to do on a problem like this would be to draw a right triangle. And if you draw a right triangle, it would look something like this, or at least this would be one of the options. Now the good thing is, in an equilateral triangle, halfway through it is exactly at a right angle, which means that we have a good idea of what this length is, because this is going to be 2. We already know this is 3 and this is 2, and then this length is going to be 1/2. And so the length of the base of this triangle is just 7.5. But then we've got to look at the height. Well, the height is, we know that the length from here to here we can find because it's just the height of this triangle. Well, in an equilateral triangle, you remember that the angle is 60, and this is a right angle, so we've got a 30, 60, 90, where 1/2 is the short leg, and so 1/2 times root 3, or root 3 over 2, is this length. But we also know in the triangle on the far right here that this is also the short leg of a 30, 60, 90, because that's a right angle, because it has to be. And so if 2 is the short leg, then that means the entire length of this segment is going to be 2 root 3. But we just want this portion of it, so it's going to be 2 root 3 minus root 3, which turns out to be 3 root 3 over 2. So the length that we needed is 2 root 3 over 2. So using the Pythagorean theorem, 7.5 is 15/2, so we'll call it 225/4, 15/2 squared, plus, well, I need to square 3 root 3, and so 3 root 3 squared is just 9 times 3, which would be 27 over 4, and that's going to be equal to x squared, which is what we're trying to find. So all we need to do is take the square root of, x is going to just be the square root of 252 all over square root of 4. And if you look closely at this one, it's divisible by both 4 and 6, so actually divisible by 36. And so 252 divided by 36 is going to give you root 36 times root 7, or root 4. And you may notice that root 36 over root 4 simplifies to root 9, and the square root of 9 is 3. And so the length of the hypotenuse IF, or the distance we're looking for, is square root 3 times the square root of 7.